All right, guys. Lesson 1 and 2, we build content. Lesson 3, activities. I'm looking at doing 4 questions today, if possible, 4 activities. Hopefully we can get through. And when I say activities, I start from multiple choice. Now, I told you last week to remind me to start from here. And I want to quickly do that before we continue. Although we did 1 question last week. Draw graphs of different reaction comparing speed and quantity. I'm going to write this because it looks ugly. Yeah, it's my OCD. Draw. Okay, now why will I say draw? Graph of different reaction rates and quantity. Okay, so guys, I am going to start quickly. This will take me 5 minutes or so. Then we jump into looking at questions. All right, graph of different rate, the reaction rate and quantity. So I have 4 graphs here. And definitely, since this graph is increasing, this becomes my what? Product, because we're producing. And this becomes my time in seconds. Now you would notice, let's call it graph A, B, C, and D. There's something common to A, B, and C. You would notice the quantity produced is the same. Quantity produced is the same. Quantity produced here is the same. Okay, in terms of quantity, let's look at it. A, B, C have what? Same quantity produced. You know what that means? It means that the same amount of reactants were used. Same amount of reactants were what? Used. But then, what do I notice from this graph? Let's use a green one to draw. There's something we spoke about. This is TC, TB, and TA. There's something we spoke about. We said when the line becomes straight, it means that's the maximum quantity produced. But you would notice something in this graph, that although they have produced the same quantity, their time frames are different. Which one do you think has the shortest time frame between A, B, and C? Talk to me, guys. I want to hear you. Which one has the shortest time frame between A, B, and C? So both of them have, all the 3 have produced the same quantity, but the time frame, and we are dealing with the rates. How fast? Okay. All right, beautiful. So we see that C is the fastest here. So reaction C has the shortest time. Reaction C has the what? Shortest time. Hence, the fastest. And what would you notice again? It also has the steepest gradient. If we were to calculate the gradient, you would notice that C has, okay. So that's the comparison between A, B, and C. A is the slowest. So it could have been any of the 6 factors that we discussed. We discussed 6. What about reaction D? Reaction D has more produced. You can look at the graph there. You know what might have caused this? More reactants present. More reactants were used. Hence, a faster rate of reaction as well. A faster rate of what? Reaction. Guys, are we good? Are we okay with this explanation? The topic is quite straightforward. It's not, but it's technical in terms of language. That's chemistry. But the topic in itself, quite straightforward. So if you were in lesson 1 and 2, this page would make a lot of sense. Did you miss 1 and 2?
Missed 1.
1. Okay. I think 2 was where we discussed the conditions. Yeah, the most. So 1 was more of introduction, what happens with reactions, and blah, blah, blah. Guys, I want us to answer multiple choice questions, and I want to trust the notes that I have. I already have about 20 slides or 21 slides of notes. Okay. And I want to believe that I don't need to write any other notes. I'm going to even start showing you where the answers are for you to believe so much in the notes. Here's our first question. Please read. Read the first question carefully. Multiple choice. Guys, I need answers?
Answers?
Yeah.
Just, in all honesty, I would say addition of calculus, but it makes no sense.
No. Can I show you where these answers are? So I want you to go back and look at the notes to say, okay, these notes are worthy. Okay, guys, look, you've seen the graph, right? I'm going to go back and look. Are you seeing on the right hand side? We're going to go back and look for this exact graph. It's called the Maxwell-Boltzmann's what? Distribution curve. That's, I've seen one. Is that not the graph? That is exactly the graph. And it falls under what? Temperature. And so we're done with that question. I did a detailed explanation of what happens, but let me quickly help everyone again to see. My correct answer is what? B. But quickly, let me explain the issue of temperature. When temperature increases, what happens? Particles gain kinetic what? Energy. What happens when they gain kinetic energy? They move faster. If they move faster, what happens? They collide faster. If they collide faster, what happens to the rate of reaction? It increases. Okay. All right. Now, if we look at these two things here, usually your activation energy is right here. And only particles that have enough kinetic energy will react. So the particles that will react are the ones here. The ones that have enough energy above activation what? Energy. Please, I want you to focus on this graph I'm going to highlight now. That's the graph we have there. Only these guys are reacting. All of these guys are not. To make it easy, I use a simple example to say, if this is your school gate, to go out of the school gate, you need a minimum of 20 rand. That is your what? Activation energy, the minimum amount of energy. Now, on a particular day, not everyone would have 20 rand. Some people don't come to school with money. They come with lunch box and whatnot. They have 0 rand. They are far from the school gate. Most people have, some people have 5 rand, they are somewhere there. Some have 10 rand, rich kids. They're there. A lot of people have between 5 and 10 rand. These ones have 12 to 15. Number is decreasing gradually. 18. Now, all these ones are the ones that have above what? 20 rand. They go out of school. They are the ones that react. Now, if the principal now decides, let's give everyone 2 rand each, what happens? There were some people who were sitting on 19 rand who couldn't go out before, 18 rand who couldn't go out before. Remember, this is the population of the school. Most people are in school. Yes. Now, if I increase the money of kids, some can now go out. What will happen to the population of kids at school? It decreases, and that's it here now. And many can now go out. Can you see that more are now out? More particles are now reacting. That's done with temperature. So with temperature, this one, don't be deceived. The one that is looking high is the low temperature. The one that is looking low is the high temperatures. Because with high temperature, more particles have moved from inside to outside. So this is the graph of temperature. And it's called the Maxwell-Boltzmann. Yes, your question?
So the number of particles have decreased.
Number of particles below having low energy have decreased. The one having high energy have increased. They now have high energy above the activation what? Energy. Lindela, there you go. Are you okay? Lindela, are you there? You got to make it fast. All right, guys, let's go look at a full. So we're going to look at multiple choice and look at a full question for every paper. So this is, I don't even know which paper this is. This is what? This paper is Eastern Cape 2023. Okay, beautiful. So we look at multiple choice. I don't want to run away from multiple choice. We like doing that. Okay, we're going to look at this graph. Immediately I look at this question and I see that there's a syringe. You know what they use a syringe to do? To collect gas. Some questions will have that and ask you to label that apparatus. That apparatus is a syringe. And this one, you must also know it. It's called an Erlenmeyer flask. Or I know you might forget what Erlenmeyer is, so you can just remember conical flask. It's examinable, they'll ask you to label. It's just a conical flask. Alright, and they'll ask you to label this, it's a gas syringe. Conical flask. Okay, now, I'll come back, we just want to read the whole story. And I wanted to see that once you understand this topic, you just be, it's 2-1, 2-1, 2-1, 2-1. Stoichiometry is 6 marks. Okay, first set of questions, we'll answer them here. And, can you see how long it is? This is 19 marks. And for those of you that came in earlier on, there's a graph here which I drew that is similar. That's where I started today. Okay, my good learners. You can even use a lot of common sense here. The only problem, like I said, you can't use street language. You have to use chemistry language. Okay, please let's read. We're going to read together. I'm going to read slowly. A group of learners investigate the relationship between reaction rate and constant. Let's pause there. If I say concentration, what do you know? The higher the concentration, the higher the rate of reaction. If I were to take you back, I want us to revise as we move forward. I'll take you back to the note on concentration. Where is my concentration note? There we go. All right, quickly everybody, the one on the right, just going to read through. Concentration, number of moles per volume. An increase in concentration means that there are more what? Particles available per unit volume. And look at, I try to demonstrate here. If you look at 1, there are 7 particles there. If you look at 2, there are 15. But the sample space remains what? The same. Where do I have more particles? 2. Where am I likely to have more collisions? 2, because there are more people now. So there are more particle samples in 2. Since C equals to N over V, and V is constant, the higher the number of particles, the higher the concentration. How will I answer it in an exam? Copy and paste this. Increase in concentration. More particles per unit volume are available. What happens after then? The number of effective collisions per unit time increases. If that increases, the rate of reaction increases. We're done. And here is your Maxwell-Boltzmann distribution. This is your first concentration. Remember, it is these particles that react. Now, if I add more, like you have a teaspoon of sugar in a cup of tea, you keep the tea the same and you add more. What are you doing? Increasing the particles, concentration. More particles are now available. Do you see that the space here has increased? We're done. Maxwell-Boltzmann distribution. Case closed. And that's it there. So now you have an idea, even if you were missing in action, you have an idea of what the examiner is now working with. So we're going to go through together. All right. They use the reaction between calcium carbonate powder and excess. They've written that excess for you in capitals. Something is going to happen on that. All right. At 25 degrees Celsius, the balanced reaction is given as though the apparatus, Okay, let's study this before we look at the questions. Experiment 1. What do you notice? I think that's one that's different, right? The volume remains what? The same. The time taken for experiment 1 is 5.28 minutes. I want to ask you a question. Looking at this concentration, which reaction would happen faster? Is it 1 or 2?
2.
Is it reaction 1 or reaction 2 that will happen quicker? Talk to me. And what's your reason?
The amount of particles, the amount of concentration has increased, therefore the amount of particles have increased, causing there to be more collisions as volume remains constant.
All right, so it is going to be reaction 2 because of higher what? Concentration. You're right. When you say higher concentration, number of particles will increase. Number of effective collisions, that line is very important. Number of effective collisions per unit time will increase. Rate of reaction will increase. I want to ask you a question. The value of y, should it be greater than 5.28 or smaller than 5.28? That's a very tricky one. Greater or smaller than? Talk to me. Greater or smaller than?
Smaller.
It's going to be smaller than because the reaction rate is faster. You've got to be careful with high reaction rate and little time. It's like going to the mall. If you drive fast at a high speed, use a shorter time. They want to play tricks with that time. Okay, guys, smaller than. Let's answer the question. Define the term reaction rate. It's there. I don't want to write. Why? I want to take you back to the notes. All right? What is my reaction rate? It is the change in concentration of reactants and products per unit time. Where did I define that? There we go. Rate of reaction is the change in concentration of reactants or products per. In this topic, you must always mention per unit time consistently. Everybody good? Answer is already written down in the note. Don't want to waste time. Name the apparatus needed for this investigation that is not shown in the sketch. Ooh, let's go check. This reaction, okay, beautiful. What is this reaction? Look at this.
Less than 0, it's exothermic.
Okay, this is exothermic. Okay, so we don't need, because if it was endothermic right now, they would say probably we need heat. Okay, let's see what is needed that is not sketched in. At 25 degrees. Let's see. That's a solid. Okay, something that could be needed, I see. We could measure the mass of this. We could measure the mass. You know why? As a gas is evolved, what happens to the mass of this? It's going to decrease. Because the gas is what? Escaping. And that's one of the ways of measuring the rate of reaction. So, a scale. A scale is missing. A scale is missing. 5.2. A scale is missing. It's water here. Give a reason why the temperature of the reaction mixture does not remain constant during the reactions. Temperature is not constant. It's exothermic. Which means what? Heat is released. So temperature is not remaining what? Constant. It's like you light a candle. Automatically it becomes hot. Temperature is not kept constant. Oh, thank you there, Mohammed. Exothermic. Will time y be longer or shorter? I think we answered that already. What did we say? Shorter. Explain your answer to question 5.4 by referring to collision what? Theory. I am done. It's what we're reading. Guys, when I said copy and paste, that was what we're reading. But let's just write it here. It's 2 marks. What did we say? Which one? Experiment 2, right? Experiment 2 has what? More particles available. More particles available. What's the reason? Why do we have more particles? Due to higher concentration. And don't write many stories. Higher concentration. And then what's the impact of that? The number of not collisions. Effective. Not all collisions lead to reactions. It must be effective. Number of effective collisions. There's something I said that you must always write. Per unit time. Because its rate increases. I have my 2 marks. If you can just get this note, copy, paste, copy, paste, copy, paste, copy, paste, you're done.
The question might just be now final.
This is a final paper, or this is a prelim paper. That's so we are looking at exactly what would be in your paper, the tone. That's what's going to look like. Are we okay, everybody? Are we okay? Take some time, read the note, you know. So we're done with 5.5, right? Lovely. And you would see it's 2, 1, 1, 2, 2, 2. But if you don't know it, you just be seeing 0, 0, 0, 0, 0, 0. Especially the language used. Okay. What I can do is, I don't usually do it, but I can do it for you, is to send you this as a PDF.
Yeah, I need the notes.
I don't usually do that, but I'll do it this time. Is this visible enough? The stoichiometry 5.6 and 5. Okay, let me do this. Let's do this. I want something that is very visible. Let's cut 5.6 out. And I see the stoichiometry here is 7 marks. Okay, look at this. In experiment 1, exactly 250 cubic centimeter of carbon dioxide is produced in 5.28 minutes. Calculate the average rate of production. If you were here, I told you the examiner will tell you what they need you to calculate with. Let me show you. I'll go back to my note. Should you then get this note, I want you to value it. Look at this page. Calculating rate of reaction. All right. I told you that when you see moles, they'll tell you what unit. Moles per GMQ, you are using concentration. Grams, you are using mass. cm cube, you are using what? Volume. Moles, you are using. So the examiner will tell you what you should use.
Always applicable.
By giving you the notes, by giving you the units. Okay? Let's see what they give us. I hope it makes sense, guys. Let's see what they gave us here. Where is it? Okay, look at what they gave us. They said calculate in what?
CM.
What is that? That is volume, change in volume, over change in what? Time. So they said in experiment 1, exactly 250. Watch out for the units. And what? That's the easiest mark you will find in a chemistry paper. So I already know 5.6.1. How do I get my rate of reaction? Use the unit. It is going to be what? The change in volume over change in time. And when we say change in volume, it is final volume minus. Since it's a product, initial volume was 0. They want to see that 0 substitution. So final volume is what? 250 minus 0 over how long? 5.28. Put that in a calculator, we're done.
Imagine saying minus 0 for the
That one doesn't matter. You can put it minus 0. Are you giving me an answer? 96,90 cubic centimeter per. We're done. Case closed. I don't 3 marks. Easiest 3 marks. Yes?
I got 47,35.
It's your friend that gave me this answer. It's Shamil.
Yeah, you got 2,5. 5,2.
Huh?
I don't know. Moment is right.
It's Shamil that gave me this answer. So when you see him, you must beat him up. What do you say your answer is?
47,35.
47.35. Thank you. And that's why I always like when everybody, tries to get the answer and not just chill. 47.35. Is that correct, everybody? Thank you, Oratile. All right. Thank you, Mohammed, for... Yeah, when you see Shamil,
Just seeing paper is away.
Oh, he said he's seeing if you guys are really there. Okay. At least now, theory has been proven. Shortly after reaction 1 is completed, the flask is sealed tightly and it is found that 100 cm cube of CO2 has escaped out of the flask. Let's read again. After reaction 1 completed, 100 cm cube has escaped. Calculate the mass of what? CO escaped out of the flask. Okay, makes sense. Let's read again. Shortly after the reaction experiment 1 is completed, the flask is sealed tightly, and it is found that 100 cm cube of carbon dioxide has escaped. That means we have produced what? 100 cm cube. Is that fine? Calculate the mass of carbon dioxide remaining in the flask after the flask is sealed. Take the molar volume. My beautiful learners, let me take you through stoichiometry again. I'm going to go back, and I want to show you something here. I wrote a little note on stoichiometry. Stoichio. Every variable is connected to what? Number of moles. There's nothing you are looking for that is not connected to what? Number of moles. Okay? So number of moles in the center. We can be told to find mass. We can be told to find concentration. We can be told to find number of particles. We can be told to find volume. And this is your recipe. Whether you're doing acid and base, whether you're doing whatever. 4 points. Mainly, you will not be given the number of moles that you need to use. But here's your first step. Calculate the number of moles that what? Reacted or formed from another compound, whether a reactant or product. I'll show you now. Use mole ratio to transfer the number of moles from what you have to what you need. Now, once you get the number of moles of what you need, you come back here and use the appropriate formula with that. Let me demonstrate that with you and show you. Please follow through. I'm going to take you through very, very slowly. What are we looking for again? Let's go back. Let's go back. It says shortly after reaction 1, experiment 1 is completed, the flask is sealed, and it is found that what? 100 cm cube of what? 100 cm of carbon dioxide was produced, right? Calculate the mass of CO2 remaining in the flask after the flask is sealed. All right. Take the molar volume. Now, we are looking for what? Mass. Take note of that. Mass of what? CO2. Let's use this page as a rough page. If I'm looking for the mass of carbon dioxide, definitely I know number of moles is what? Mass over molar mass of carbon dioxide I can find. Periodic table. That's 44. Carbon is 12. Carbon is 12. Oxygen is 16. 16 times 2 is 32. 32 plus 12 is 44. So to get the mass, what is missing? So that's my aim. If I can get that, then I'm done. But how do I get that? Let's go back and write the reaction. What's our reaction? What do we have? Calcium carbonate, right? Calcium chloride. Okay. We have calcium chloride. I want to see something. Okay. Plus hydrochloric acid. I'll get a fresh page now and we write that equation and see what the examiner is all about. Okay, so what do we have? Calcium chloride plus hydrochloric acid, usually calcium carbonate. This is creatine. We will produce calcium chloride plus water and carbon dioxide. Please, it must be balanced all the time. Yeah, we have it balanced now. All right, let's go back. Now, shortly after experiment 1 is completed, the flask is sealed. Okay, so they allow the experiment to go through. Flask is sealed tightly. It is found that what? 100 of carbon dioxide has what? Escaped. Calculate the mass of carbon dioxide remaining in the flask after the flask is sealed. Now, this is after the 100 cm cube has what? Escaped. This is what I'm thinking we should do. Why don't we find the total volume that was produced? Okay? By the way, don't we know the total volume? They said exactly 250. Okay, hold on. Exactly 200. This one is actually simpler than I thought. Please, you got to follow the story. Total produced is what? 250 cm cube. Escaped is what? 100. What is left? 150. So this is left. All we need to do is to convert this to what? To number of moles. No, we have to convert this to mass. But how do we convert this to mass? Remember, I am looking for mass. Watch this. Number of moles is mass over molar mass. But this is what I don't know. Because this is what? 44. But where do I get the number of moles from? And I'm given volume. There's another formula that connects this together. Volume over what? Molar volume. Do I know my volume? 150. Do I know the molar volume? 25,000. Please watch the unit. Also in what? cm cube. So we're good. 25 what? This is number of moles of what? CO2 that is left. And all we are doing is converting this one to what? To mass. Once I get that, since number of moles now is mass over molar mass, what's my number of moles? 150. Please don't round off. Over 44. And we are done. 4 marks in the bag. This one is not even normal stoichiometry, it's common sense. Please give me an answer and let me know. Let's discuss if it's okay. This one is more common sense than stoichiometry. Give me an answer across my... Yes, Shamil. No. Do the steps. It's not going to do it for you in the exam. Do the steps by yourself. Yes, let answers come in. Cross multiply and divide. I'm seeing 0.264. Is that correct? Let's see, guys. If you're not getting it, let me know. 0.264. Show me, what do you have? Two decimal places. What are you doing? Why are you dividing by 44? Can you take a pen, please? Take a pen. Do the cross multiplication and that first. And work it out. I'm going to wait for you. I'm going to wait for you. I'm going to wait for you. Please make sure you do it well. We don't want to assume that you know it. We want everyone to get it. This one here, examiner is just trying to say, do you have sense? Do you have chemistry sense? It's not really... Huh? You sure?
Yeah.
Okay. Guys, everybody okay with that? Everybody okay with the steps? All right, let's go for the next question. What is the next question saying? Where are we? We're done with the stoichiometry part, right? So we now need to answer. Guys, I want to try. Let me see if I leave you to answer this. Can you answer? Can you answer? I'll give you, try. Let me give you 5 minutes. Just digest. We are looking at rate of reaction. We have points factors that will affect. Let's look at it. There's a bit of acid and base here.
So this experiment on.
Sorry?
The same as compared to the experiment on.
Yeah. Compared with experiment 1. What's your experiment 1? Okay, let's write the details of experiment 1 quickly. What's our experiment 1? What was it? Concentration is what? 0,9, right? Guys, volume will never affect anything here. Okay, so we are looking at concentration of HCl, which is what? 0,9 and 5,28. That's what we need. Let me write that information for you there. So experiment 1, where's my pen? Experiment 1 has what? 0,9 moles per dm cube HCl. And it's used 5,28 minutes. The graph of carbon dioxide produced for both experiments is the same. All right, beautiful. Do you know why it's the same? We use the same amount of calcium carbonate and the same concentration. Do you notice the concentration is the same? Okay, let me stop the time. Let's read. The learners now add 50. The volume was the same. Excess what? Ethanoic acid. What is the concentration? 0,9. So the concentration is the same. 0,9, 0,9. What changed? The acid. Now there's a bit of acid and base here, which you needed to know from grade 11. Ethanoic acid is a weak acid. All right? Ethanoic acid We'll mention this more when we do acid and base. It's a weak acid. HCl is a strong acid. Okay. Now, which graph, P or Q, represents experiment 3? Which one do you think would be faster? The one with a weak acid or the one with a strong acid? It's the one with a strong acid. That's nature of reactant. The one with a strong what? Acid. So, which reaction is faster? Let me ask you. Is it Q or P that is faster? Let's see your answers. Q or P? Which one is faster? Q. How do you know it's Q? Oratile, you said A. So if you look at the time, Q is faster. Right? Good. Experiment 3 should be what? Q. Remember experiment 3. No, sorry. It should be P. Why? Originally, we used what? HCl, strong acid. Now we are using what? A weak acid. So reaction becomes slower. So XP is slower than what? Q. It took a longer time. Explain your... All right. I think that answers it. Ethanoic acid. And I want us to look at the answers. We're going to look at this. This document has answers. Ethanoic acid is a what? It's a weaker acid than what? Hydrochloric acid. So number of effective what? Collisions. That's how I would have answered it. Per unit time is smaller, or is just small. Hence the rate of reaction decreases. 5.7.3. How does the amount of calcium carbonate used in experiment 1 and 3 compare? Do you see that they produce the same carbon dioxide? So if they produce the same carbon dioxide, that means they were using the same amount of reactant. What's my answer? Equal to.
Is there another way to do 5.7.1 without the knowledge of acid and base?
No. Because it's about concentration. It's a stronger... You see, if you understand, if you have done acid and base very well, I will have said, it ionizes... When you say something is a strong acid, let me quickly explain. It means it ionizes more than a weak acid.
Yeah, it produces more of those H3.
Good. And if it produces more of those, it means we have more particles available for reaction. That's it. So the idea is to have more. Once you have more particles available. So because it ionizes more, it produces more ions, which is what reacts. Done. Give a reason for your answer for 5.7.3. I think we answered that. How do we know? Same level of carbon dioxide was produced. Same volume of CO2. I want to see some of the, I want to see how the answer is produced. Okay, I'm done with 19 marks. Guys, I want to see something here. I want to see some answers that they got. So we are done with that paper. This document is question and answer. This is, okay, end of the paper. Eastern Cape. Do you remember the question for one multiple choice? What question was it? 1 point what? Was it 1.4 or 1.5? I don't remember. Let's check. 1.5. And what's our answer? B. Okay, we're good. 1.5b. Then we went on to question number 5. Let's just check, All right. Define rate of reaction, change in concentration of reactants per unit time, or change in amount of moles per unit time. I showed you all the formulas. So any one of them is correct. And if you want to write Afrikaans, you're also welcome to write. Okay. Oh, nice. Stopwatch is missing. Yeah. But we also measuring, but mass is also something that is missing. But yeah, stopwatch, good one. Reaction is, we got that one correct the way they told. Then we got the shorter perfectly the same way. Experiment 2, did we get that right?
Higher concentration, yeah.
Yes, higher concentration. Let me zoom it. Higher concentration results in more particles colliding with correct orientation. The number of effective collisions per unit time increases. That must be mentioned. 250 over 5,28. You see where the marks are? The 250 and that. All right. Yeah. 0.26 grams. So we're good. Did we say P?
Yes.
Yes. Yeah?
It's 5.61. 0.95.
What did we get? Can we do that?
47.35.
I'm sure they made a mistake because 250 over 5,28 would never give you 0.95. It's an error there. It's an error.
I should put 0.95. But I put in the wrong way. Yeah, you put in the wrong way. So they also put in the wrong way.
Yeah, it's Shamil's uncle that set this paper. But we can clearly calculate and see that something is wrong there. All right. Oh, did I take a picture? What's going on here? All right, so it's an error from them there. Okay. 0.26. We got that correct, right? Did we get P correct?
Yeah.
Yeah. All right, we got it. It's a weaker what? Acid, which will result in a lower reaction what? Rate. Did we get that correct? Equal to. Why? Final amount of CO2 is the same. We're good. Okay, lovely. Let's go to the next province. So guys, when you're done with the topic, please do things like this, answer and check. Where are we? Free State. I think this document has about all and this is 20. All right, 1.4. Multiple choice. We are not running away from any answer, any question. 1.4. Okay, you answer. Why do I keep doing this? Oh, I see what I keep doing. So it keeps deceiving me. 1.4. There we go. Got it right. Please answer. Multiple choice. Will not affect. And I mentioned it. I mentioned this. I mentioned this while we were talking. It's like I saw this question coming. There are 6 factors. You must know the 6. Listen to me carefully, then choose the answer, right? 6 factors. First, think of how many phases of matter do we have?
I know the answer. Okay.
How many phases of matter do we have? 3. Solid, liquid, and gas. For solid, it's surface area. For liquid, it's concentration. For gas, it's pressure. Pressure always. Then we have 3 others. Temperature, catalyst, and nature of reactant. Please check. There's one I didn't mention. Give me answers. No. There's one of them I didn't mention. Put the mixture in hot water. That's temperature. Right? Use the same mass of powdered magnesium what? Use the same mass. What do we have here? Magnesium what? Ribbon. Here I have what? Powder. Because it's a solid, this is surface area. Increase the volume, that's my answer. Here, concentration. And I mentioned, I said volume has nothing to do with this thing. Are we okay, guys? Multiple choice, very key, please. 6 factors, and we didn't talk about what? Volume in all the factors. All right, let's go. Wait. Chain reactions, chemical equilibrium. That's our next one. Or maybe I should just continue with chemistry and finish it. You know why? Your school most likely will start with physics because there's no time for June revision. It's quite tight. Exams are starting in May. Yeah. So maybe I should continue with chemistry. Your school is doing physics. By the time I get to physics, they'll be doing chemistry. So you'll be doing both at the same time. I don't know if that makes sense. So with us, we will be revising physics that you would have done. With them, you'll be revising chemistry that we have done. I think that could work. That could work. Otherwise, we are not going to have time for... What are you smoking, boy? Guys, answer this question. This boy here is talking something. That 4 hours is not enough. Okay, please, let's answer this. Glucose is metabolized in the human body through the following simplified equation. The graph below shows the energy change. Is this endo or exo? We spoke about it. And this is grade 11. Exo or endo? And I'll teach you a way to identify. Can I show you something very simple that will help you? Look at this. And this must play in your head all the time. We have 2 of them, right? Okay, check this. There's a guy here.
That's what I just said. Yeah.
And there's a guy here. The guy wants to exit this thing. Where is it easier to exit? Is it 1 or 2? No, the guy's going to jump.
This one, yeah.
And look, this guy is going to jump and right be feet. This guy is jumping. When he jumps, it might that. So where is it easier to jump? Yeah, where is it easier to jump? From 1. So it is easier to exit from 1 when this one is lower. So what is this? Exothermic. And what's your reason for it being exothermic? Delta H is less than 0. Or you can say H product is less than what? H reactant. Is this explained in my note?
Yeah.
Let's.
I was there. It's explained.
You were there?
I was there.
Aha. There we go. Experiment 2. Exothermic. All right. So just know that delta H is going to be negative. So note the graph first. Ask yourself, will I jump from something high or something low? Do I want to kill myself very quickly, or I want to delay my own death? What are you saying?
Passing away seems easier than passing physics.
Never. Passing physics is easier than passing away, man. Passing away is a lot of work, eh? Because you have no control over it. At least physics, you have control.
You might fall, like, you can help us here.
Okay, guys, let's go to 5.2. So I just noticed this one was not in order. Okay, 5.2. And keep learning as we are dealing with all of this. Oh, what do they want? They want us to... Oh, beautiful, beautiful. All right? This is grade 11. Express the following in terms of values of A, B, and C shown in the graph. What is the activated complex? A, B, or C? Huh? Activated complex, A, B, or C? Can I get answers from you guys? Activated complex is A.
Alright.
I'm going to go back to my notes.
I see.
At least by now you must know that, okay, this note it's the real deal. You should know that this note is the real deal. There we go. Check. Is it mentioned? There. A is the activated complex. And I see that in this question they're talking about reversible reaction. And I dedicated a full page for it. I dedicated a full page that when it comes to reversible, the reactants become the product and the product becomes the reactant. And we always measure activation energy. Please look at this. Let me re-highlight this for you. If I look at the forward reaction, highlight. If I look at the forward reaction, that product and what? Anytime I'm measuring my activation energy, it must be from the top to where the reactant is. Now, if I reverse the whole thing, what happens? This becomes my reactant, and this becomes my product. Where's my activation energy? From the top to that point. Because you must measure it to where the reactant is. Do you think we can answer these questions now? I'll give you 30 seconds now to answer the 3 questions. They said in terms of A, B, and C. You have 30 seconds. Quickly, everybody. Thirty seconds. Activated complex? A. Activation energy of the reverse. A minus C. because
Oh, yeah.
it's measured from here to here. So we're looking at that space. A minus C.
I'll express the following in terms of
Delta H for the forward reaction. Remember your delta H is always what? H product minus H what? Reactants. What is the product? C. So it's what? C minus B. Grade 11 there. Grade 11. I hope it makes sense, everybody. Please, as we are revising grade 11, let's take note. Okay, let's move to the next one.
That's how you're supposed to use now grade 11.
Huh?
No, grade 11, we got it wrong. It's A minus C. You have to do a sum. You were just thinking A, B, C.
Okay, let's do this. Let me get an investigation. All right, I want to crop up to 5.2.4. So you see that in this topic, once you know your story, you don't waste time at all. In an investigation, the rate of reaction, excess 200 cubic centimeter solution of HCl concentration is what? 0.5. Produced at STP. The spontaneous reaction, the volume of hydrogen gas produced at regular intervals is measured and shown. Okay, so we have the volume produced. Total volume is 414.4. Define the term concentration. Ooh, number of moles per unit volume. I'm taking you back. This note is a prediction of all question papers. Huh? Like what? Check there. It's defined. Concentration. So those of you that have this note and you've not really paid attention to it, I think I'm calling your attention back now, right?
So this is like our holy scripture purpose.
This is your?
Holy scripture purpose.
Absolutely. Concentration is the number of moles of solute per, and this one, please don't stress, use the formula. What's your formula? N over V. What is N? Number of moles. What is V? Volume. That middle line is called per unit. We're done. So it's number of moles per unit what? Volume. Next question. Use the formula to define. Why is this giving me page 3? Okay, something happened here, I don't know. Can't find my lesson 1 and 2. Alright, let's go on. I need to deal with it. Write down the limiting reagent for the above. Go back. This one is easy. They said in an the problem is we don't read. They said excess of HCl. So which one is limiting? Zinc. But somebody is busy calculating now. It's zinc. We're done. Calculate the mass of please, stoichiometry. I want you to enjoy. When I see this, I'm always happy because it's free marks. Examiner wants me to calculate what? The mass of zinc. Let's start by, I want you to analyze, and I'm going to ask you to do it. So please listen to my analysis. You are going to do the calculation, just to check. We have zinc chloride and what? Hydrogen gas. What am I looking for? That's where I start. I'm looking for what? The mass of zinc. Okay. Hold on. To get mass, what do I need? What's the formula? Number of moles is mass over. Okay, molar mass we can get quickly from the periodic table. 65, I think. All right. What is missing? Number of moles. Okay. And my statement number 1 says, they will not give you the number of moles that you need. What are you supposed to do? Find the number of moles that reacted, or that is what? Produced. Okay, what is produced here?
H2.
H2. Oh, beautiful. But what do I know about H2?
It's in thingy volume.
I know the volume. Oh, the volume of H2 is what? 414, comma what? 4. Can I then find the number of moles here? Yes. Because I have volume. Number of moles is what? Volume over molar volume. And they told me the molar volume, this is at STP. All right. And what is this? This is 22,4 dm cube. This one you get from the periodic from the formula page. Okay. Take note of the units. dm cube and cm cube. All right. So, please check. All I need to do, I have this. I have this. Can I get this? So find the number of moles. When you are done with that, you are going to come to step 2 and say, okay, look, what's the mole ratio? Zinc and hydrogen gas. Mole ratio, you look at the number here and the number here. Oh, it is what? 1:1. Whatever number I get here, I am now looking for this. It's going to be the same. And this is this. I throw that in as N and I get my mass. I want you to try to calculate. Molar mass of zinc, 65. Let's confirm. And guys, if you can see that, that is how stoichiometry is built. And then we are done with this.
When you convert it from cm cube to dm cube, you divide by 1,000.
From what?
From cm cube to dm cube.
cm cube to dm cube, you divide by 1,000. Let's see. You are welcome. Where is zinc? Yes, zinc is 65. All right. Number 30. Zinc is 65. And you would see your molar volume, the second block in the second one in the block there. 22,4 what? dm cube. 65. And this is 22,4 dm cube. So molar volume, 22,4 dm cube per mole. And if you want to convert this one, if you want to use cm cube, you can just say 22,4 times 1,000 cm cube. And if you want to convert cm cube to dm cube, you divide by 1,000. Please quickly get me answers. Let's try this 5 marks. We have 4 minutes. I have done the main work, guys. I have done the main work. The main work was to explain, and I did. Let's see what you got by you just listening. Are you done? Oh, what's your answer? 1,2 grams. I have an answer already. Let's confirm. Let me see your working. What did you write down? Don't do it in your head. Right. You have 3 minutes. Write down the way you're going to write in an exam for me. Quickly. Quickly write it down the way you would have written it in an exam. Please. Remember we spoke about this. So I need answers. Start putting your answers there when you're done. Okay, I'm seeing a lot of 1,20. And whether you are doing acid and base, whether you are doing that's your stoichiometry. You will say I used a blanket recipe, which is what we applied here as well. So for me, what I do with my stoichiometry, I first analyze before I start writing. What do I have? What do I need? What do I need? So I get my steps, then I walk backwards now. Okay? So, first thing is to calculate the number of, and I want to show you how I do my write-up. Some of us, we do the write-ups and we get confused along the way. I like to say number of moles. I like to specify what I'm looking for. Volume over what? Molar volume. If I divide this by 1,000, what will it give me? 0,4144 over what? 22,4. So they are both in dm cube now. Whether you convert the other one to cm cube as well doesn't matter. What's your answer? 0,0185. At least 4 decimal places. Very important. Moles. Of which compound? Hydrogen gas. Then I'll come here and say, okay, zinc and hydrogen ratio 1:1. If this one is 0,185, what is the number of moles of zinc? Cross multiply, right? So the number of moles, check. I like to write all of that in. If I cross multiply, what do I have? 185 what? Moles of what? Zinc. Now I know that number of moles is mass over what? Molar mass. 0,0185. We said the molar mass is what? 65. Therefore, if you cross multiply, what's your answer? 1,2 on the dot.
Yeah. No. Over 2 zeros. 1,2025.
1,2025. Let's see. 1,2025. Okay, which is the same as 1,2 grams. Guys, I don't know if the 5 marks is very easy. Straightforward. Okay, are we good, everybody? The same mass of zinc granules is used instead of zinc powder. What is the difference between granules and powder? Which one has more surface area? Wait, let's look at granules and powder. Your sugar is not powder. Your sugar is granules. Can I grind it further?
Yes.
So if I can grind it further, that means if I grind it further, it becomes a powder. So powder has more surface area than granules.
Yeah.
Does that make sense?
Yes.
Because if I take one sugar, I can still have it as crumbs, right? If I press it now, I have more that were molded. So powder has more surface area than granules. Wait, let me see something. Let me see something. Let me see something.
It has to be this.
Eh?
It has to be this. Yeah, definitely. So in the pictures also.
Yeah. Oh, here, you see, I wanted to include chips. We should include granules in between here. Then to powder. Because from chips, we can break it down further to granules. Granules can be grinded further to powder. Okay, I was trying to just show the different. That's a ribbon there. You have your chips there, and then you have that. Okay. Because I think I remembered I didn't put the word granules. All right, let's see. How will I answer this question? The same mass, which means we are going to produce the same volume. What will be different? Time frame. It's like somebody leaving your house and going to the mall. Somebody walks. Somebody uses a bicycle. Somebody uses a scooter, and somebody drives. We will not pass the destination. The destination is the mall. You wouldn't say because you are driving and then you drive past the mall. So our destination is to produce 414,4. The difference is how fast we produce it. Okay. How will the rate of how will this affect the rate of reaction? Increase, decrease, or remain the same? What? Instead of powder, it it will decrease.
Yeah.
Just by listening to my explanation now, it will what? Decrease. And why will it decrease? Now, whenever you explain this, you'll always see that collision theory there. Okay, I would say that granules have what? What? A smaller? No, smaller. Smaller what? Surface area than what? Powder. Okay, now we want to see how will this affect number of particles available for collision decreases. Does that make sense? When you mold, it's like taking something and mold it. Some particles are now hiding. They're not exposed. What would happen? The number of effective collision per unit time does what? Decreases. And then what happens? The rate of reaction does what? Decreases. Granules have smaller surface area than powder. Number of particles available for effective collision will decrease. The number of... Alright, so let me see. We have 1 mark for A here. This is A. 1 mark. You'll get 1 mark here. You'll get 1 mark here. Do you notice this one is the same as that? And that's your 3 marks. Are we okay, everybody? Let's see. Are we okay? Answers are basically the same in this. Once you just answer 1, 1, 1, 1, 1, 1, answers are basically the same. I promise you. 5.2.5. Okay, let's go back. We came here to get formulas. We are done. Oh, 1 question remains. 2 marks. 2 beautiful marks. A suitable catalyst is added to the reaction mixture. Redraw the graph. Okay, where's the graph? Above. Where's the graph? Oh, there we go. Okay. I'm just going to copy that graph again. Redraw the graph. It will be below this time around. There we go. Redraw the graph above in your answer book and label this given as A. On the same set of axes, sketch the curve that will be obtained when catalyst is added. Wait, what is a catalyst? A substance that speeds up, which means here I'm going to use a shorter time. Does it mean I'm going to produce more?
No.
Good. My graph is now done. Once you understand that. One is fine. I don't want to have multiple. Well, they have different catalysts will increase at different paces. Yeah. Guys, did this make sense? No. Did this make sense? Okay, can we mark this? Do you remember all our answers, right? I think we have an idea of what all our answers are. Let's go check. Okay, guys, work with me. I want to just see the language. Like I said earlier on, it is the language that matters in chemistry. What is our multiple choice again? 1.4. I don't remember the answer though.
C.
You sure? What was the question? What was the question even? Oh yeah, C. It was talking about the volume. Okay, 1.4 C. Correct. 1.4 C, correct. And then we move on to question number 4. No, question number 5. Okay, exothermic. Are you with me, guys? Come, let's work together. Exothermic A minus C, C minus B. I remember those ones very well.
Yeah.
The amount of substance per unit volume of water or solution. Zinc. All right. What was our answer? 1,20. Okay. We said decrease. Decrease in surface area. Fewer particles with current orientation are available. Fewer effective collisions per unit what? Time. Same concept, just different words there. Look at the graph. B and A. We're done.
So it is the range.
Yes, in case you rounded off.
Thank you. I'm working that.
In case you rounded off. But normally, the range is only available for graphs. Here, we all agree standard-wise, do not round off until you get to the end. Okay, let's see. The next province is Gauteng province. 1.4. Ah, beautiful. Did we talk about this today? Yes. Do you remember this was similar to our first multiple choice question? Let's create a page. So guys, if I close this topic today, I think I'm okay. Okay, there we go. Please answer this. Here I say nothing. From T1 to T2. Oh, I love the way they asked this one here. We should be done. Which one is the higher temperature?
T1.
T2. Welcome on board. T2 is the higher what? And with higher temperature, there is number of collisions will what? Increase. Your activation energy will not move. It stays the same. So my correct answer is A. Yeah. From T1 to T2.
Oh, yes.
T1 is cooler. T2 is hot. So the number of collisions has what? Increased. My answer is A. Guys, are you okay with the explanation? The only thing, thank you, I'm seeing answers. The only thing that changes your activation energy is catalyst.
Oh, others it remains the same.
Yes. Catalyst will lower the activation energy.
Temperature won't.
Yep. The only factor that will change that is catalyst. Okay, guys, beautiful. Okay, the other one is chemical equilibrium. So, guys, I'm just going to continue with chemistry. I'm going to move into the next chemistry topic, chemical equilibrium. So that when your schools are now, we do the reverse. So by the time I'm doing physics, it's actually revision. Physics, we are revising what you've done. In school, they are revising what I have done. Perfect idea. Perfect idea. All right, here we go. Here we go. Here we go. Go. Before we even go and copy the question, please read. I want us to see what this question is talking about. The following apparatus was used by a group of learners in an investigation to find out how surface area affects the rate of reaction between solid magnesium ribbon and dilute nitric acid with a concentration of what? 0,05. Please take note, solid surface area. During the reaction, the gas that is formed is collected in the measuring cylinder. The balanced equation for the reaction is that. The way they collected this gas is called what? Just want to remember this. I think it's upward displacement. Because what happens? The water is there, then the gas goes up above the water. Yeah. The summary of Okay, let's look at reaction 1 and reaction 2. Before we even answer the question, which reaction will be the fastest?
1.
Remember, the mass remains what? The same. The state of division, the ribbon is cut into 5 pieces, small pieces. And number 2, it's one large piece. Which one will be faster? Talk to me. Muhammad says 1. Okay, Muhammad says 1. Shamil says 1. Okay. Okay, everybody seems to be saying 1, 1, 1. Let's see the answers now. Or let's see the rest of the questions. The graph is plotted below. Graph is plotted. Oh, of reaction what? 1 is plotted below. I'm sure the graph is big enough for everyone to see. We will come back and deal with whatever information. Let's see. How many marks? 15. Not bad. I think we can answer all of these questions at once. Besides the mass and the volume of the reactant, give one variable that must be kept constant during this investigation. What are we checking again? We're checking what? Surface area, right? Okay. So what should we keep constant? We should keep temperature constant. We should not add catalyst. You see, those are so that the experiment is fair. So we can just say, at least keep temperature what? Constant. Temperature should be constant. Hold on. Apart from mass and volume, concentration should also be kept constant. Does that make sense? No catalyst added. You cannot test 2 variables at once in any experiment. I did mention that when we're doing organic chemistry. You cannot test 2 variables. You are going to be unfair. I want to test 2 of you to see who runs faster. But now I didn't give someone food. I didn't give one person food. Automatically I know that the person who has food will run faster. That's fine. I'm only testing food. Now, the person that I didn't give food, or the person that I gave food, I now gave him a car. Am I being fair? No, so you can only test what? 1 variable at a time. Every other variable remains what? If I'm giving you a car, and I can't give you a Mercedes-Benz and Uno, I'm not fair as well. Even if I want to give Mercedes-Benz and Uno, I must make sure both of you drive the same. Your heart in driving is you can hit the accelerator the same way. Then I'm testing the car now. Now I give a timid person Uno. I give a confident driver, I go look for one Formula 1 driver and give them Uno. You still have learners. I'm not being fair with the car, and I'm not being fair with your quality. All right, so one variable must be tested per time. And what is the reason? It's an exam question to make the experiment fair. Okay. Write down the dependent variable. Guys, in this topic, all of these factors are used to test what? Rate of reaction. So rate of reaction depends on temperature. Rate of reaction depends on concentration. Rate of reaction depends on catalyst. Rate of reaction depends on whatever it is. So what's our dependent variable? Rate of reaction. Throughout. Does that make sense, everybody? Rate of reaction. Okay.
So what's involved when you have a solution? Are you sensing different type of compounds or different type of compounds will evaporate at different temperatures? So let's say you wanted to separate it, you put one apparatus and you let the gas evaporate, then it becomes a liquid in the sun and it drops into this container. What's that called, that method?
Distillation. All right. Use the graph to calculate the average rate of reaction. Again, I told you they will always give you that. Can you see what they've given us? So what would that be? Change in volume over change in what? Between 2 and 2,5. It's basically you're looking for gradient. So I know my time already as what? Final time is 2,5. Initial time is what? 2. Okay, can I ask you to do this for me, everybody? Rate of reaction. Between 2 and what?
2.5.
These guys are silly. They're giving me a time of 50, 100, 150. Now I must find between what? Oh, minutes. 2 and 2,5 minutes, but the time is in seconds. It wasn't making sense. Why are you giving me so much small time? You are giving me a big. Okay, guys, please you try. Rate of reactions between 2 and 2,5 minutes in, they said what? cm cube per second. I'll give you 3 minutes to try. It's 3 marks. What is your attempt? I've already given you the formula. It's the change in. Let me move this because I don't know if it's blocking any value. 2 minutes, 30 seconds. Don't guess. You have a calculator there.
Yeah, but will 2 months be from 1 to
Convert the 2 minutes to seconds since the graph is in seconds. And now if you don't know how to convert, I must send you back to grade 8. Sit in a class with grade 8 learners at least once. You see your height, even the chair will not fit. Start sharing answers. All right. Mohammed has given me a 0,1.
It's change in volume over change in time. I got 16.
There's a 16. Kian is also giving me 0,1.
Final volume. Racist. No, man. It is.
Okay, time up. 2 minutes is what? 120 seconds? 120 seconds, 110, 120. Is that fine?
Oh my.
Do we agree with 120 seconds? And what? What is 2.5?
2.5 is 150.
150, are you sure?
And it's 120 plus 30 goes.
Plus 30 seconds, yes, 150.
20 is 48.
So we have what? 42 and 2, 4, 6, 8. 42 and 48. Okay. Once we get those values correct, I think we are good. It's more of common sense now. So what do we have? Rate of reaction equals to what? Change in volume over change in time, which is 48 minus 42 over what? 150 minus 120. What's your answer? 6:30. Huh?
For the time, you can't put it in. There's always
They said in seconds.
Yeah.
So how are you guys getting 0,1? Because I see a 6 and a 3. That's 0,2. Venusha, how are you guys getting 0,1? Can somebody tell me what you guys did to get 0,1? Mohammed, what did you do? You gave me 0,1.
So I didn't realize that the 200 seconds wasn't 2 minutes.
Huh?
So I used 200 seconds and 250 seconds. I didn't realize what I was doing.
200? How did you even think about 200?
I saw 2.5 days.
And I was very specific about those minutes and seconds. You can't just say you saw. Read. It's minutes. But the graph is in seconds. Please let's pay attention to details. Okay. And I did mention that as well. Even I got confused first and I went back to say what's going on. How can they give me 2 when they're giving me a graph of 50? That means you were not paying full attention. Will the rate of the reaction at 250 seconds be greater, less than, or equal to our answer in 5.3? Wait, 250 seconds. Where did we stop? At 150, right? Okay, where is 250? What's your answer, guys? Here is 250 seconds. Huh? Will it be greater than, smaller than, or equal to? My answer is smaller than. Why? Guys, as we progress, and I have a note here. As we progress, do you notice we are using our particles already? As the reaction progresses, what's my note? I must have a note. Yeah, look at that second paragraph. Here. As the reaction progresses, the number of particles available does what? Decreases. This reduces collision what? Frequency. So the rate of reaction does what? Decreases. The graph is not becoming as steep as before. It's even close to the end. So take note. Why is it going to happen? Because fewer particles are now what? Available. The fewer the number of particles, the fewer the number of effective collisions, the slower the rate of what? Reaction. Okay, so what's our answer? Less than. And I think I've already answered by explaining. There's no need for me to write. Give a reason for your answer. Less particles are now what? Available. Guys, 5.5. Predict how the gradient of the graph in experiment 2 will compare to that of experiment 1. Write down only increase. Didn't we talk about this? Which reaction is faster? Which one did we say? I don't remember. 1. Okay. Please answer the question. Let's go back. 1 is faster. We all agree. How will the gradient of experiment 2 compare to that of 1? Gradient is talking about whether it's more steep, equal to, or less steep. Experiment 1 is faster than 2. Anybody? Talk to me. I'm waiting for answers here. Experiment 1 is faster than experiment 2. So what will happen to the gradient? Predict how the gradient of graph 2 will compare to graph 1.
Graph 2 will compare.
Can I get answers, please? Fatima, Oratile, Victoria, can I get answers? Taisha, can I get an answer from you, please? Vokudo, Grace, Lindelwa. Sina, Amani, Awande. Come on, too many people in this class for you not to give me an answer. I see increase and I see decrease. Mohammed, you're telling me increase. Every other person says decrease. Mohammed, which experiment is faster, 1 or 2?
One.
Good. So the gradient of 1 will be higher than the gradient of 2. So the correct answer is decrease. Do you agree with me? Are you okay with my explanation?
So the person finish faster.
Sorry?
When two like finish faster,
Why?
there's a smaller surface area. So it doesn't take as much time.
Okay, look at the table again.
And it's one large piece, so it has a smaller surface area.
It has a smaller what?
Surface area.
Nope. Have you ever cooked minced meat? Minced meat. Do you cook, Mohammed? Let's use cooking. If I buy a big, why do you think they cut your meat into small pieces? To cook faster. All right? So if you buy the same size of maize and make one mince and the other one in even the way they cut it in, the mince will still cook faster because it's now in small pieces, a larger surface what? Area. Let me give you another quick example. If you take you have your double page, right? And tear it into 2 equal halves. I want you to picture this. You tear your double page into 2, so you have 2 papers now. Everything is the same, right? Yeah. Then you squeeze one into a ball. It has a smaller surface area now. You throw both on water. Which one gets wet faster? Is it the squeezed one or the plain one? The plain one. The one with the larger surface area would have a faster rate of reaction. I don't know if all my explanations are making sense to you.
Yes, sir.
Okay. So if you are not cooking, please start cooking. Tell your sister that I said she should allow you at least cook and tell them food will be ready now. Just get the meat, blend it. Blend it, make it mince. Fast. Don't put water when you blend. Cut the meat. Tell them food will be ready in 2 minutes. Take that minced meat, shove it inside the stove, cover it, 5 minutes, serve them food. Done. While they are still boiling the meat. See, apply science.
Crazy cooking. Just gonna blend the over.
You make it fast. You're done. Okay. All right, guys. May I please leave you with this stoichiometry to do for me now? I'm tired of talking. Calculate the mass of magnesium metal that remains in the flask. That remains. Assume that the molar volume is what? 20. Please write down the molar volume they've given us. So they don't want us to go to the table. Molar volume is 24 dm³ per mole. Okay. Please write down what we are calculating. Mass of magnesium that is left. Mass of Mg that is left. That is very important. That is left. Not the mass of Mg used. We want the mass of Mg that is left. Please write down the reaction. We need that reaction. Oh, I see why they said left. I was wondering. Do you notice they told us what? Okay. Please write that reaction. Mg plus 2HNO3 to give us magnesium nitrate and hydrogen gas. By the way, we have the original mass of magnesium. What's the original mass of magnesium? 2. We need that. Yeah, it's given on the table. 2 grams is the original mass. So out of these two, some were used and some were not what? Used. I'll tell you what else that you need. The graph. What is the volume produced? 60. There we go. You have all the information. 5 minutes, crack your brain. Let's see what you got. Up your sleeves. It's 5 marks. Oh, we need the atomic mass of Mg. 24. 24.
Which is the gas? MgNO3 is the gas. Not just Ag.
Mg is a salt.
Mg is okay, so H2 is the gas.
H2 is the gas produced.
So that there is
Atomic mass of magnesium is 24. Atomic mass 24. All right, there you go. You have 4 minutes and 30 seconds left.
between 2.4 is for gas.
But we're not using 22.4 now. They gave us, they said 24 dm cube.
So both of them are
What do you mean?
the mass of magnesium.
That's grams per mole. They are different units. Think, start from the equation. I told you what to do. Start sharing answers once you're done. Talk to me. I have a 1,94 grams left. Okay. What did you guys get here? What did you get?
Can I take a picture of the your everything?
What do you need it now?
Not really, but for later.
Yeah. $1,94. Let's see how to do this. Now, I will start from the reaction quickly. Let's go to the reaction. What's our reaction like? All right, it's magnesium plus nitric acid. Guys, work with a balanced, and this one in this case is balanced, I think. Mg plus what? HNO3 to give us what? MgNO3 2, so I need a 2 there. Plus what? H2. Just that. Okay, beautiful. Now let's look at, originally we have what? 2 grams. Originally. What was the volume of hydrogen gas produced? 60 something. Huh? 60. 60 what?
No, it just checked. 60 centimeters cube.
Cubic centimeter, right, I think? Yeah. 60, beautiful. And we are given our molar volume as what? 24 dm cube per mole. Okay, so let's check. So volume produced there is what? 60 cubic what? But they told us this one is what? You know what I would do? I would find what reacted.
Yeah, so standard.
And to find, listen, to find the mass that reacted, I would say number of moles is mass over what? Molar mass. Do I know the molar mass? 24. Do I know the number of moles? Nope. So, I will go to my hydrogen. Since I produce this, let's look for the number of moles of hydrogen gas. So I'm working now. Number of moles of hydrogen gas, volume over what? Molar volume. Can we divide 60 by 1,000? 0.06. Do we agree? Why am I dividing? Because my molar volume was given in dm cube. We okay there? Mole ratio. This is of what? Hydrogen gas. What's my mole ratio? Mg and H2, 1:1, right? So 0, what's giving me that value? 1 over? Okay, let's leave it at that because it's going to be 0.0025. Okay, fine. 0025, right? So what is the number of moles of Mg? Cross multiply. Are we fine there? Since that is what reacted, now we calculate the number of moles. So number of moles of Mg is mass over what? Molar mass. 0.0025. I don't know the mass. Please multiply for me. Mass of Mg is what? That what? Reacted. So this is what reacted to produce that. So mass of Mg left behind. 2 minus, oh, you guys got it correct. 1.94 grams. 1.94 grams. Guys, are we all okay? Stoichiometry is getting there gradually. Gradually. So whatever produced was produced from what reacted. So we're saying that 0.02 grams will produce what? 60 cm cube there. So what is left? 1.94. Okay, guys, let's move. Let's move. We have one more question to answer. Medications used to retrieve to relieve headaches is available as powders or tablets. Use collision theory to explain why powders provide faster. I think we're done with this. I did explain. A larger surface area, more particles are what? Available for reaction. Therefore, the number of effective collision per unit time will increase. That's why, you see, this is pure science now. You have your grandpa, it used to come in tablet before. Now you have your grandpa in sachets. If you go and check any sport, if you're active into sports, most sports, on the sport supplements, it's either liquid or powder. Even drugs. Okay, forget it. Skip that I said that. That's why the thing reacts fast. Somebody can then stand there for 3 hours as if so, all right. Somebody can stand there for 3 hours, and those guys amaze me. Just stand there, slow motion.
He's gonna fall.
Yeah, you think they're gonna fall, but they just stand there. This guy are mini Michael Jacksons, Michael Jackson is the only one that has moves. You must check those guys. Wait, let's answer. What was our multiple choice? It was 1.4. Was it C? There are too many C's in this 1.4, which I don't like. No. No, this was 1.5. Our 1.5 is A. A, correct. Okay. And we're dealing with question number 5, I think. Yeah, it's question 5. Check if you remember some of these answers. Temperature, concentration, which one is kept constant, right? 5.2, we said rate of reaction. They were asking for dependent variable. Okay. Average rate, was it 0.2? Yes. Less than, the gradient is less steep at 250. I did mention that, right? Okay. Indicating that, or look at, okay, I think I focused more on this one. There will be fewer what? Reactants left as the reaction produces. 5.5, were we correct by saying decrease? Yes, we're talking about the gradient. Experiment 2 would decrease. Beautiful. Stoichio, 1.94. You see, look at the steps. It's like I copied it. First number of hydrogen produced. My ratio, can you see the ratio is giving me 1 mark there? That is point B. That's how we mark. Then we move to point C. Okay, they did something different. Okay, well, I think we used the one on the left. We did the one on the left. Because we got our 0.06 and then that. Do we have any other answer at the end? Oh, too many options. All right, look at the last answer. Powders have what? Increased larger surface area than solid tablet. More effective collisions per unit time. All right. Let's do the last one, but you will do most of it this time. I think my jaws are now paining me. Which one is this? KZN. 1.4. Beautiful. 1.4. Oh, we've done something similar. If you remember, we've done something similar. Okay, guys, we only have 15 minutes. You got to push as quickly as possible. And the good thing, I'm sure, is you might not do the same questions at school. So which expands our what? Expands your question bank. Please answer. Please answer. Just make sure you read the question well. We're looking for the heat of reaction, right? So you should be able to answer that as quickly as possible. Shamil, you have an answer for me? You will just only start reading now.
No, I'm thinking.
This guy. Awande has a D. Your heat of reaction is always between your products and your reactants. So basically you are looking for this. I love how they did this one. So basically, this examiners are, this is X. Oh, nice. Okay. So you would notice that the whole of this is X, right? And the whole of this, if we are measuring from the same point, it's more physics than chemistry. Is Y. So what's your answer? Does this thing have anything to do with Z? Nope. Z is not starting from the same place. I don't know if what I'm saying makes sense. Look, what we are interested is in this part, right? Just this part alone. So I have to, there's called what we call reference. Frame of reference must be the same. So I know, think about vertical projectile motion. I know the distance from this point to this point as X. From the same point to this point as Y. So what is my that? X minus Y. Tricky one, lovely one. Yeah, I'm correct. X minus Y. So take note of the point of reference, right? They start at the same point. We'll check the answer. We have 10 minutes. Ooh, let's see. I don't want to keep you. 10 minutes. Wait. Is there another multiple choice here? No chemical equilibrium there. Okay, guys, 10 minutes. Hopefully this one will not be long. 16 marks. Okay, not bad. 1 page. But so that for visibility, for quick visibility, we're going to quickly run in terms of reading to see what this examiner is really working on. All right. Manganese dioxide catalyzes the decomposition of hydrogen peroxide. All right. You will see that manganese dioxide is not even there. Basically, it's just a catalyst. Okay. Manganese dioxide of mass 0.1 kilogram was added to the flask containing 200 solution of hydrogen peroxide. Concentration is 0.2. The oxygen gas produced was collected at standard temperature and pressure, and the volume measured by a syringe. So we have a graph like that, right? The reaction stops before all the hydrogen peroxide decomposes. Do you know what that means? It means when the reaction finished, we still have hydrogen peroxide that did not decompose. The reaction stops before all of it decomposes. Okay. Let's fetch the questions. What am I doing? Let's fetch the question. Guys, you've got to be fast now. We have only 5 questions. Just 5. 5. At least get something correct. First one. This one is free gift. How long did it take for the reaction to stop?
9 minutes.
How long did it take for the reaction to stop? 9 minutes?
I would say about 10.
About?
9.
Let's see. Can I get answers quickly? The gentleman here says 9 minutes. And I'm getting, from those at home,
You know what it is?
a different answer. And their answer is 7 minutes, which is correct.
7 minutes.
Yes, sir.
Up to
Yeah,
the
because
beach.
it's
nonsense questions.
They want to trick you. If you're in my lesson 1, I did mention this, that the reaction stops immediately the straight line starts. Because even if I were to continue 10, 11, 12, 12, the volume remains the same. All right. It's like you get in the mall and then you stay in your car. You didn't arrive at the mall when you went into the shop. You arrive at the mall when you passed the gate. Whether you now receive a phone call in your car is your business. But your ticket starts counting. You understand what I mean, right? Okay. So the first answer is what? 7 minutes. Okay, beautiful. At least we've learned that. Number 2. How does the volume of oxygen gas collected compare for every minute as the reaction progresses? How does the volume of oxygen gas collected compare for every minute? So you're looking at 1 minute, 2 minutes, 3 minutes, 4 minutes. Talk to me, everybody. Let's hear. I've answered this question today, though. Hello, everybody. Talk to me. Is it decrease or increase? Increasing.
Yeah, it's increasing.
It's increasing.
Yeah.
Okay, I have increasing.
Yeah.
Huh? Why are you saying it's increasing, though?
Because 2 is bigger than 1 and 3 is bigger than 2.
What do you mean?
The gradient is increasing.
Can I get answers? I don't know if it's network, but I'm not getting answers from you all. Talk to me. Can I go back to the question? Read the question again. How does the volume of gas collected every minute? So look at in the first minute. Look at the first minute. We produced 38. In the second, it's now 60. So it's 28 there.
Yeah.
No, 22. For the first minute, we produced 38. In the second minute, we produced what?
Look here.
Wait, as the reaction progresses, what happens to the quantity of product? Good, and that is what determines how fast the reaction is. Once your reactant starts decreasing, the rate of reaction will also what? Decrease. Let's explain again. For the first minute, do you see we produced 38?
Oh, I see. You're saying the difference between the...
That
Okay, yes.
in the second minute, just this part,
Yes,
it's 60 minus
For 38.
38, which gives me 22.
Yes.
In the third minute, can you see now? In the third minute, it's 20. In the don't lose marks.
I said
Okay, so what's the answer? Decrease. They're silly questions, but very, very tricky. Decreases. And we did explain that, right? Because as you are using, reactants are reducing. What mass of manganese dioxide is present in the flask after 8 minutes? 1 mark? I'm sure it's not. What mass? Yes, this one is the lovely one. What mass of manganese, not hydrogen peroxide, manganese? Okay, I've got a 0. Fatima says 0. Muhammad says 0.1. I need 2 more answers. If I can get 2 more answers, you have a 0.
It can only be 0.
It can only be 0.
Yeah, no, I couldn't say it can be 0. Yeah,
So,
no, wait, it's a catalyst. It's the catalyst.
Yes, I'm here. I'm listening to you.
It's a catalyst.
isn't catalyst when you speeds up the reaction,
0.1,
doesn't it you stop?
Yes. The catalyst.
Yeah, I'm waiting for answers from others.
The catalyst don't get you there. It's 0.1. Is it a catalyst?
Guys, it cannot be 0. It's 0.1.
Yes. Okay.
A catalyst is a substance that speeds up the rate of without itself taking part in the reaction. So the correct answer is 0,1. It's not used up. I'm saying it's not used up. I like explaining a catalyst as let me give you a good example of a catalyst. Not really kind of a spectre, but I come to you now and I say, Shamil, do you know what Muhammad said about you? No, I'm spilling the tea. Then I go to Muhammad, if you heard what Shamil said. Now the two of you are going to meet each other and you are going to fight. And nothing happens to me. I am a catalyst I'm speeding up the rate of your fighting. But I'm not taking part in the reaction. Both of you end up in hospital, I go to school. So the answer is 0,1. Guys, did that make sense? It does not take part in the reaction. Use collision theory. Fully explain the shape of the graph from the time the reaction starts. Guys, can I go back? I want to show you what this answer is. It's in your note. And I've gone there today. We are explaining, please look at, we are explaining the shape. Okay, it's too detailed. It's only 4 points that you need. But I wanted to read the story. When the reaction starts at t equals to 0, there are a lot of particles available. I need that statement. So that's 1 mark. This causes collision frequency to be high. Hence, a very fast rate of what? Reaction. Which represents what? A steep slope. All right? Either lots of reactants are used or lots of products are formed in a short space of time. That's what it means. As the reaction progresses, the number of particles does what? Decreases. This reduces what? Collision frequency. So the rate of reaction does what? Decreases. My second point is there now. This is shown by a gentle slope, indicating that it takes longer for a reaction to occur. The graph hits a straight line, showing no more decrease in reactant usage or product what? Formation. The zero gradient shows that the reactants have been used up. I get another mark there. This is the end of the reaction. Similarly, no more product formed irrespective of time. This is area C on the graph. I drew 2 graphs. The one on the left is reactants because it's decreasing. The one on the right is product because it's forming. So if it's a reactant, it starts from the top and starts going down. If it's a product, it starts from 0 and starts increasing. Guys, I'm not going to write answers there. I'm tired as well. Yeah, because I'm just saying the same thing. Answers are in the note. So use collision theory. Fully explain the shape of the graph, which I've explained. Please don't write too many things. 4 points. When the reaction starts, lots of particles are available. All right? A high rate of reaction, and the gradient is steep.
Yes.
As the reaction progresses, what happens? Particles decrease, gradient becomes gentle. And at the end of the reaction, particles are used up, gradient is 0. I'll show you the memo. We can take a picture. Ooh, wait. Look at the last one. Use. Do we need to do this before we go? Use the information provided and the graph. Calculate the what? Concentration of hydrogen. Let's run through it together. What are we looking for? Concentration of hydrogen peroxide remaining. Beautiful. Let's quickly get our equation. Let's write it. We start by writing the equation. Oh, it's hydrogen peroxide to give us what? Oxygen and water. Let's quickly write this together and solve. 9 marks. I want to see what the 9 marks is all about. 2H2O to give us what? 2O2. 2H2O plus O2. We're going to finish just now. Let's see information that we know. We are looking for what? Concentration of hydrogen peroxide remaining. Okay, so we are saying remaining concentration is unknown. Okay, let's go back to the question. What do we have? Don't worry about the 0,1 grams. Oh, that one is irrelevant. What do we know? The initial concentration is what? 0,2. Okay, initial concentration is what? 0,2. Let's put the word initial so we don't get confused. And definitely we need what was produced, right? What was produced is 118. Do we agree? I'm lying. Each of them is 20. No. 2, 4. Wait, that's 20, right? 20 divided by 5 is 4.
Yeah.
That's how we calculate it. Let me highlight so that you see what I'm saying. Guys, look at this. 120 minus 100. That's 20. And there are 5 lines there. So 20 divided by 5 is what? 4. So from 100, I go to 104, 108, 112, 116. And 116 what? cm cube. Is that fine with us? Okay. 116 volume produced. Okay, my good learners, let's try. Volume produced is 116, and we're told it's at STP. And STP is what? 22,4. It's similar to what we did earlier on. This is what we produce, right? Let's find out what produced that in terms of concentration. So first is to convert that into moles. What would that be? 0,116 dm cube. Please give me an answer quickly. 0,116. 0,0051. Okay, moles of what? Oxygen. Mole ratio. H2O2 and O2. 2 is to what? 1. Are we good? Then what will that give us? 0,0051. If we cross multiply, what will it give us if you cross multiply? 0,0102. Okay. Okay, 0.2 moles of what? We have 4 decimals, so it wouldn't really make a difference. But are we okay so far with what I've done? So it means the number of moles that we used is that now. Number of moles, wait, concentration is number of moles over what? Volume. Ooh, did you check the volume? Let me write this very well. Concentration of what? H2O2, right? Is number of moles over volume. What's my number of moles? 0,0102. What is the volume? They give us a volume. I don't remember. 200 cm cube. But remember, in this case, I have been converting to what? dm cube. Divide by what? 1,000. Please give me an answer. This is the concentration used. 9 marks in the bag. We'll check the answer now. What?
0,2526.
Don't round up yet.
2589.
25.
Is it
something is wrong.
0,0102.
0, yeah.
2 is 0,051.
I can't be getting something greater than 0,2. 0, what?
051.
0,01.
Oh, 0,051.
Okay, there was somebody who raised a hand. Yeah, 0,051 moles per dm cube. This is what is used. Now remaining, which is excess. Original was what? 0,2. Give me an answer to this one now. This is our final answer.
Should be 0,196.
Stop lying.
It's 0.1,
4.
1, 4, yeah.
149.
Yeah, 1.9.
Which is what?
0.15.
It's very similar. It's exact same thing that we did with the one you did for maths, where you had to subtract what was left. I don't know why they said this is 9 marks.
Yeah.
But may we please check quickly, and then we are done for the day. Let's check. You remember all our answers? Hopefully. But when we see it, we know.
Yeah.
Multiple choice is A.
Multiple choice was A, right?
Yeah.
But that was 1 point.
4.
You sure?
Yeah.
Huh? 1.4A. I don't trust that 1.4. That yeah, but it's 1.4.
Okay.
1.4A. Okay. 1.4A. Then question 5. Let's go to question 5 quickly. 7 minutes. Decrease. 0.1. This is the 4 marks, right? Rate of the graph decreases as the reaction progresses. Rate of reaction decreases. Concentration of that decreases as reaction progresses. Number of effective collisions. Okay, but if you explain the way we explained, you get your answer. I'm interested in the final answer here. Final answer, 0.15 moles per DMQ. This one just gave 9 marks for nothing. Okay, here's the step. All right, your formula got 1 mark. And then 0.0016 over that, you got 1 mark for that answer. Then mole ratio, you got another mark. Then for calculating initial, here they used initial concentration, which is the same, but final answer. Yeah, I want to see the one, here they use the table. We'll be learning more of that table. But it doesn't matter. Our answer is what? 0.15 moles per DMQ, and that's what I have. Guys, I hope it's okay. Stoichiometry is also in place. Please go through these lessons. I would advise you, since your school is going to probably start with physics, the weekend before you start, it's just 3 lessons. Just go through it, It makes it easier for you to, when you get in class, and just quickly comparing notes and adding here and there and there. Remember, we do not have time. Exams are starting in May. And term 2, let me let you see. I can share the syllabus with you. In term 2, we have 6 topics. Work, energy, and power, Doppler effect, rate of reaction, chemical equilibrium, acid and base. Actually 5, but they are heavy. Work, energy, and power is quite heavy. Doppler effects are simple. That one we can do in 1 lesson probably. Well, chemical equilibrium is not easy. It's heavy. It's one thing people cry about. All right, which will start next week. All right, guys, but are we okay so far? That thing has a table, and the table is 9 marks. When they tell you to calculate KC, 9 marks. Sometimes 10 marks. Are we all okay though, guys? Are we okay? Look at this table. Yeah, that's the table. Okay, in this case, it's 7 marks. That's the table we're talking about. So, but once you understand the table, it's all good. All right, guys, have yourselves a lovely evening. Please, let's talk on the group. I would love to start, if it's possible for us to have a class tomorrow so we can start chemical equilibrium. I don't know yet. We'll talk on the group. Just keep yourselves informed. But if not, then we'll start next week. But I would love to start.
For redox reactions, is it possible for them to give us a reaction that's not in the table?
No, all the reactions.
I told you.
Good night, guys.
Sir showed us how to do it this time.
Last year, you went to us, so.